To understand a data lakehouse, we need to take a step back in time to the late 1980s when businesses needed to expand from simple relational databases to systems that worked for larger quantities of operational data. Data warehouses were devised as a way to collect and consolidate this influx of data and provide support for overall business intelligence and analytics. The data in a data warehouse is usually structured and clean with a predefined schema. However, data warehouses are not designed with semi-structured or unstructured data in mind and thus become very expensive when trying to store or analyze any data that doesn't fit the schema. As companies grew and the world became more digital, businesses' data collection increased drastically in volume, velocity, and variety, making data warehouses less favorable. Additionally, streaming and transactional data became challenging to incorporate at speed. So data architects began looking for a different way to manage all the influx of big data. In the early 2000s, big data was front and center as data architects tried to solve the problem of storing and analyzing such large volumes of data being generated at such high velocities. Enter the data lake. Data lakes allowed businesses to store large volumes of structured, semi-structured, or unstructured data in various formats together in one location. Multiple streams of data can be quickly and cheaply stored together in low-cost cloud object stores like AWS S3, Azure Data Lake Storage, and Google Cloud Storage. However, while data lakes solved the storage dilemma, it introduced additional concerns and lacked necessary features from data warehouses. First, data lakes are not supportive of transactional data and can't enforce data quality, so the reliability of the data stored in the data lake is questionable, mostly due to the various formats. Second, with such a large volume of data, the performance of analysis is slower, and the timeliness of decision impacting results has never truly manifested. And third, governance over the data in a data lake can cause some challenges with security and privacy enforcement. To address these concerns, data lakehouses were developed as an open architecture combining the benefits of a data lake with the analytical power and controls of a data warehouse. Built on a data lakehouse becomes a reliable single source of truth for all the data for that business in the data lake. Lakehouses, like the Databricks Lakehouse, offer several key features such as transaction support, schema enforcement, and governance, BI support, openness, and more. The Lakehouse supports the work of data analysts, data engineers, and data scientists all in one location. The Lakehouse essentially is the modernized version of a data warehouse, providing all the benefits and features without compromising the flexibility and depth of a data lake.